Hello and welcome to my first stream. First, I wanted to say thank you to Tony for encouraging me to stream. My good friend from work. He's a streamer himself, and he got me hooked on this. So let's see how this goes. All right. For my first project, I want to repair / upgrade these keyboards. I have a pair of these Kinesis Advantage keyboards. They are they're ergonomic keyboards. Let me just turn down the volume for a bit. They are ergonomic keyboards. They're super comfortable. I love them. I have one for home and one for work. And yeah, they're awesome. The only problem is that this is a Generation 1 keyboard. Both of mine are Generation 1 keyboards. And this specific one was manufactured, I believe, in 2002. So that's pretty old. I've owned it since 2003, so it's got like, what, 15 years of use in it. And the keys are still awesome. The mechanical keys, it's all Cherry MX Brown switches in here. I read somewhere, I think it might have been on Kinesis' website, that actually Kinesis contacted Cherry to develop the MX Browns to begin with. So in a way, I guess this keyboard's sort of responsible for the explosion of mechanical keyboards that we see now on the market. But one thing that sucks with this first generation of keyboards is that the function keys, so the top row here, and there's another sort of half over here, they are rubber dome keys, and those pretty much suck. I mean, if you've used like an old calculator before, or a gamepad or something like that, you know what those feel like. They're kind of mushy. You know, they don't click when you push on them. They wobble. You can see that they kind of, you know, you can push on it on the edge. You can push on it all the way in, or you can push on it on the other edge. It's not a great feeling. It doesn't always register the button press. And the thing is that the way these things work, basically you've got some pads underneath. They look like, you'll see them, I'll have to take this apart very soon, but they kind of fit together like fingers, but they don't quite touch. And the button comes on top of this and presses down and basically makes contact between the two sets of conductive fingers. And the way it makes contact is that on the bottom of the rubber dome, there is a thin layer of graphite, which is a conductive material. And what happens is, over time, the graphite kind of wears out, the rubber wears out, so the shape of the dome, you know, it becomes uneven, and so you have to push harder on the key, and then that wears it even more. And yeah, it's not awesome. And so what happens is, you know, what, maybe like 5-ish years ago, I'd say, I started having problems with my function keys. You know, sometimes they wouldn't work so great. And so I opened it up, and, you know, I cleaned them, and that gave it another year or two, and then eventually, you know, I started having to clean it, you know, more and more often, and eventually they just kind of gave out, and I wasn't able to get them to work anymore. So I applied the usual strategy when you run into rubber dome problems, which is to open up the switch. And on the underside of the graphite, you basically just take a piece of foil, so like either aluminum foil or copper foil. Usually it's adhesive backed, so like a tape kind of thing. And you cut little squares, and you stick a little square of foil on the underside of each rubber dome, and that helps it make contact. And that extended it for another maybe 6 months, maybe something like that, less than a year. And then eventually, you know, the foil kind of falls off, and I see that when I hit the table, the camera vibrates a little bit. That kind of sucks. I'll have to find a way to remedy that. I'll be careful for the time being. So I was saying, yes, that the tape eventually falls off, or it moves inside, and so now I've got this kind of worse problem where some keys don't work at all. Some keys, they just fire randomly, which is terrible when you're programming. Like, there are specific keys that do specific things when you're executing, and it's very bad. Even playing games, it's terrible. It's just sending random commands to the game at any time. And I can hear my own voice from the other room. I think somebody's watching in the other room. Somebody I love. All right. Yeah, and anyways, it sucks. So my goal actually is to do what they've done with the second generation of these keyboards. And what they've done is super smart. They essentially got rid of the rubber dome idea, and they use these switches instead, which are Cherry MLs. These switches are made by the same company as the other switches that are in the keyboard, except they're L for low profile. Anyway, you'll get your chance to see a lot of these. I'm not sure why the camera's not focusing. Is it focusing at all? Oh, hope you don't mean your cat. No, my cat's not watching, unfortunately, but it's not too far. So these switches are mechanical, and in the second version of the keyboard, those switches are actually in the top row here. They're full row of switches, and the feeling is a lot better, and it's awesome. Now, you might wonder, why don't I just buy new keyboards? Well, as it turns out, they're pretty expensive. I live in Canada, so I think these days those go for like between 450 and 500 Canadian dollars a piece, which is not cheap. So replacing both would be like $1,000 or so, which is pretty steep, you know. I mean, most of the keyboard still works. Plus, it's got a ton of history, right? So why not try at least? Yeah, that's pretty much it. I've got a bag actually of Cherry MLs here that I just got from Germany. Got, I think, 50 keys, so I've got a couple to spare. I think total I need 36 for both keyboards to replace them. And they actually have another project here that I'd like to try. I'll show you something. So one problem we have with these keyboards is that, well, you'll see it when I open it up, but it's got a very sort of particular shape on the inside. You can see that it's, you know, it's curved. A lot of it is sort of custom injection molded plastic. They're actually put together by hand. You'll see there's a lot of through-hole components and everything in there. I will be designing a PCB, a printed circuit board, that will fit here in the top section of the keyboard and replace what's in there right now. And I'll be mounting the switches on the PCB. And I thought it'd be interesting actually to kind of try to use my 3D printer to tackle that problem. So obviously the 3D printer is well suited to the task of designing a shape that'll fit inside this keyboard. It'll mount properly, screw in place and all that stuff. But I actually want to kind of take it a step further. For last Halloween, let me get this out of the way for a second. Last Halloween we had to build 8 or 9 circuits for our costumes. We have these radio hats that would communicate with each other. And you could push a button on the hat and, you know, it would light up the other hats and stuff like that. There you go. And so what I've got here is a bunch of prototypes from that time. I didn't wind up using this technique for the Halloween costumes because we kind of ran out of time. But here is a good idea of what this might look like. You can see here that I've got, like, basically it's a 3D printed piece of plastic. I wish I could control the focus on that. There we go. 3D printed piece of plastic, and I've got some copper foil on there. And what happens is I actually ran the foil all the way over the parts that kind of stick out, and I just ran a thin knife down the tracks to make these separate traces here. Now, as it turns out, my final design for this technique I think is going to be a little different. I'm probably going to be doing something a little more like this, where everything gets printed flat and there's no relief. And then you kind of just run the knife down it. I think it's actually going to be a little easier that way. This was a bit of a more, you know, and you can see, sorry, on the underside of the print that I was trying to do like a dual-sided PCB here, which didn't turn out great. It turned out to be a little ambitious for a first effort. But what I'm planning on doing is actually just forgetting about the underside of the print, which generally doesn't turn out so great when you have little details like that, and just focusing on the top side, which has nice finish. My printer can do, even though my printer is inexpensive, you'll see it, it can do nice top side finishes. So my idea is actually to 3D print the circuit, use this technique, cut between the traces to actually to put together the circuit for the replacement circuit for the top of the board. And I think that should work. I have some I looked at the circuit in there already. It's pretty simple in the original keyboard. Yeah, I gotta stop banging this desk. Sorry. And yeah, that's it. So let's take apart the keyboard. Let's jump right into it. Not forget about the switch. Oh yeah, so I guess there are different parts to this. Obviously, I'll need to design the circuit physically so that it fits in there. I'll need to design the circuit logically so that it actually routes the signals properly to the control board, or the main board, the motherboard, I should say, inside the keyboard. And obviously I'll need to assemble everything. And also there's another problem or question, or interesting design question, is these little keys. I'm not sure you're going to be able to see this, but they have these two little slots in here. Maybe this one. Yeah, you'll see them up close. If not, I'll grab some nice pictures. There we go. They have 2 slots in them, and those 2 slots are meant for little plastic prongs. And those plastic prongs go into the keycap, what we call the keycap. Now the keycap on a normal keyboard is much bigger. This is a keycap, this is a keycap, but the keycaps for the function keys are going to be much smaller. So those are not normal, those are not standard sized. These switches are made to go in keyboards, and Cherry makes the official keycaps that go with it. They make them in the factory somewhere. But I'm going to need to design my own keycaps that are much smaller to fit into these holes. Turns out I saw online a guy's already kind of done this kind of job before. I believe he had a different version of the keyboard though. I think his already had PCBs, like proper PCBs in the top row. And he used Lego 1x1 bricks as buttons, and just a row of differently colored Lego bricks. It was really cool. But I think I'm going to go through and all the way through and print some keycaps for this. So I'll probably kind of interleave the jobs, while the 3D printer is working, designing something else, and so on. So without further ado, let's take this guy apart. So there's 6 screws to undo here. Let me just pull out a plastic tray a little bit so I don't lose anything. Put the keys in there as well. All right. It's actually a nice thing to take apart. It's got some nice thick screws, they're not hard to handle. The plastic is super robust and you're not afraid to break anything. The only thing you kind of have to be careful about is... Oh, thanks, Daru. Thanks for letting me know about the shake. Glad to hear it. Let me know if it gets out of hand. Alright, I was going to say there's this cable here that connects both halves of the keyboard. Let me make sure I don't lose any of those screws. You don't want to pull on that cable too much. It's got a connector, so you can take it apart. I am sorry for the appearance of the inside of that keyboard. I am a master of the so-called wipe and type technique, which means I frequently eat at my computers, and so my keyboards take the brunt of it. Alright, I will disconnect this connector, and here we go. We can set this aside for now. Alright. So, as you can see here, this is the original PCB. You'll see, I'll take it apart in a second. It's got a flexible ribbon here, and you'll see the rubber domes behind this. And here, there used to be these plastic posts in the, before I ever took it apart. I had to cut those out because unfortunately the way they mount this is that they put this big plastic plate in there, and then they use some kind of a hot iron or something, and they melt this black plastic over it, and so it kind of just holds it in place, but it's a permanent thing. You can't really get this plate out of there again without having to cut the plastic. So it's the same thing over on this side. What I need to do, unfortunately, is I actually need to just remove the hot glue that I'd put there, and then get to work on removing the rest of the internals. And I will do that right away. You can actually see here where it connects to the main board. It's just a simple ribbon connector. I can actually take that apart right now. Just pull on the white housing a little bit, if I can get my fingers in there, my sausage fingers. There we go. One, and it's out. So now you can see it's kind of floppy. I'll try to do this one on this side so you can see a little what I'm doing here. And there we go. Pulled out the connector and pulling out the cable. All right. What I don't plan on reusing these right now. I will probably either solder to the underside of this connector when I solder my new boards, or I will actually, more likely probably, seeing how this is mounted in here, I will probably desolder these connectors, these white connectors here, and I will probably replace them with either a new connector, or I'll just solder the wires directly to the board. I'd like to use a connector though, because it's nice that this thing is kind of modular. You can take it apart to clean it. I guess I'll see when I get there. I'll have to make a call. All right, so without further ado, take out the alcohol and a knife for the hot glue. So this is actually a popular trick for getting rid of hot glue, or not getting rid of it, but to dislodge things that are stuck by hot glue. You can use rubbing alcohol. And it doesn't really dissolve the glue so much as, I'm not sure exactly how it does it, but it really weakens the glue's holding power. I'm not sure why. I learned that trick on the Flight Test channel, which is a super popular YouTube channel. You should check them out. They make remote control planes and stuff. Plus, I mean, alcohol is harmless to electronics, so as long as it evaporates properly, and as long as there are no impurities in there. So you see the glue, I don't know if you can see this, the glue is really just coming off there. It's no problem at all, as though it wasn't even there to begin with. Boop. I just use this knife to scrape it off, and then once I've got all three little blobs done, I should be able to take out the PCB. Give this one another little shot. Here we go. I think I put it through. There we go. Alrighty then. And here comes the plastic plate. I said, here comes the plastic plate, thank you. And then, aha! So you can see what's going on here. Alright. Over on this side, you've got some foil that got unstuck from my function keys. You can see that the function keys themselves, there's still a couple that have the foil on them. Yeah. Alright, there we go. And yeah, basically this is why the keys are just so wonky. You know, here this one, the foil is completely off the rubber dome. These ones are not too bad, but yeah, they're function keys I don't use really. So this one, the F5, is completely gone. It's stuck there, and it's actually making contact between two of the pads. So these black things are the fingers I mentioned earlier, where will it focus, will it not? It's a bit like a game of bingo. How to figure this out? No? Yes? No? Alright. Yeah, so if the foil here makes contact between these two pads, I mean, it's conducting electricity, and as far as the keyboard is concerned, the key is down, is not good. So my goal is going to be to reproduce effectively this printed circuit, but with mechanical switches. I'm going to start by removing pieces of foil, so I won't need those anymore. Oh man, they're really like, oh man, and the graphite pad is coming apart. Oh man, it's really old. I lost a bit of foil here. There we go. Get the rest of the foil off. I might as well take it off the rubber domes as well while I'm at it. All right, let me get some tweezers. Sorry, I'm kind of working off camera here. Got to get out of that habit. Or move the camera, one or the other. All right. Just removing the pads here. I don't really need to do this. I might as well we're not going to use this anymore, so might as well kind of sort of pseudo restore it to its original condition, as worn out as that might be. All right. Mostly I just don't want little bits of metal flying around and getting stuck where they shouldn't be. All right, let me do the other half of this this keyboard here. A little bit more alcohol. All right. You can really feel the difference where the alcohol is penetrated and where it hasn't managed to enter, because where the alcohol has gone, man, the bond is super weak. It just gives in and doesn't even resist. And it's pretty fast too. I mean, the weakening of the bond occurs over seconds, maybe. All right, put a bit more in here. All right. See, it's just coming right out. Boop. And it's clean too. It removes all the glue. It's not like there's any residue behind or anything. All right. There we go. Gonna take out this bit of plastic. Normally you could actually remove the finger bowl on the side for this. Strictly speaking, not completely required. As long as you're willing to use a little bit of force. All right, there we go. Oh, that's right, I hadn't put foil on this side. I hadn't done this side of the keyboard. And it's completely worn out. That half the keys on that side don't work at all anymore. All right. All right. So I need to keep these for reference for now. They're not actually symmetrical, I believe. Wait, this was like that. No, like this. Okay, this is the proper side. Nope, like that. All right. So, are they symmetrical? Nope, they are not symmetrical. They are not symmetrical. You can see that here if I put them side by side. Not quite. All right. A little bit more glue here. I'm just gonna try to clean that out. Actually, it's not glue. It's, I don't know what that is. Some kind of food, probably. All right, let me just clean up here quickly. All right, move the keyboard off to the side for a minute. Put all this stuff away. All right, move these parts out of the way. Just give the desk a little wipe. All right, now I think the first thing I should do is probably figure out the footprint for these switches, and yeah, the footprint for these switches, and sorry about that, and figure out how I'm gonna 3D model this, and then I'll probably look at the circuit boards and reverse engineer that, or, well, that's a bit of a strong word for what this is. Copy the layout, make sure I understand it, make sure I know how to lay out the switches so that they fit. Actually, that's a good point. I checked, I measured beforehand. I got to make sure that the switches here, they fit in these holes, or rather that, yeah, basically that can fit it. Oh, it actually fits super nicely. Ooh. Oh, this is tempting. Oh. Wow, this is almost too good to be true. What's going on there? There's like these little brackets here, these little ridges between each of the holes, and the switches fit perfectly in between there. Well, almost, do they? Okay, they did in the other direction. Wait. Wow. That's amazing. They really fit in the hole like super well. Almost as though they had some kind of an idea that they were going to go forward with this upgrade in the future. Wow. Or since Kinesis got the MXs designed for this keyboard to begin with, it's possible they did the opposite. It's possible they actually built the Cherry MLs so that they would fit these grooves. That's incredible. Wow. That's pretty impressive. All right, and is this fully flat? It is not. So there's a bit of a curve here towards the inside. However, let me just have a quick look down these. So however, the inside here, the inside is completely lined up. It's completely flat. But the outside, the keys are kind of, the groove is a little curved. I don't know how to explain that. You can see it here, that there's a bit of a curve. If I put it this way, can you see it? No, maybe, I don't know. There's a bit of a curve here in the front of the keyboard. What happens actually if I lay down this switch right here in the middle of the track? Kind of lines up nicely with the hole. If I can hold it in there. Okay, wait a second. All right. It does line up super nicely with the hole. Now, I've had a super flat key switch, not key switch, sorry, keycap. I mean, this would be like a home run. Mechanically, this would be super solid because each switch would be well seated within the grooves. Oh, this is amazing. Okay, I like this. I didn't expect this at all. I don't know what the odds of this happening are, but not very high. All right, so step number one. Oh, my keyboard's putting crap all over my desk again. It's so dirty. All right, sorry about that. I will then, this is OBS now. I will then switch to Fusion 360, and let me just check there. You guys have got, yeah, you can see, all right, properly. I will start designing. Let me just make sure, can I double check this? I think I can. I can. All right, seems to work properly. All right, not going crazy. All right, so I'm actually remote desktop into the other computer that's in the room right now. That's actually the computer that's streaming out. What I will do is I will grab the datasheet for these switches, and I will model. This is Fusion 360. It's CAD software from Autodesk. It's awesome. And I will model these switches in there. Well, at least I'll model the footprint. And then what I'll do is I'll make a very small test print with my printer to make sure that I can that the switches fit properly and I've got all the dimensions right. Because the thing is, sometimes when you print the plastic, you know, it's a little bit thicker, it oozes and stuff like that. It's not super precise. So you gotta adjust your tolerances to make sure everything fits properly. What I'm gonna do right now is, before I model this, I'm actually gonna just quickly start up my printer and print a calibration run to make sure that it's ready to go a bit later. I will show you the printer quickly. This is what it looks like. makes a bit of noise, it's a little noisy. It's fortunately I damaged it recently. I stuck a screwdriver in there while it was running. I broke a fan blade, so now my fan is little lopsided, but it won't be very long. All right, it's going. So here we go. Let's grab the data sheet. Oh, sorry, I just saw your message, Daru. I'm having trouble monitoring the chat while I'm using the laptop. I'm not sure what you were referring to when you said that's a cool trick, but maybe the alcohol on the hot glue. I'm not sure. All right. So, see here, I've got the dimensions, all the dimensions that I need. Anything else? So that's actually interesting here. These are the normal keycap sizes that Cherry Ghost makes to work with this thing. All right. The printer's heating up. All right, so what I'm gonna do is I'm gonna move this to the side. I'm gonna zoom in on the part that interests me. Okay, Fusion for some reason doesn't like being snapped half width. All right. I'm just trying to make sense of what's what here. Okay, so this is interesting. See, there are two versions of the switch. One of them has a jumper wire from here to there. Now, I purposefully did not get the jumper wire version because I knew that the original switches did not need the original PCBs did not need jumpers to work properly. So, yeah, I kind of hesitated there, but I just wanted to make sure that I had the least amount of trouble to deal with in terms of number of pins. I wasn't sure whether I have enough space or whatever to fit the extra pins I wasn't going to use, so I just didn't take a chance. All right. So does this give me diameters for the pins though? It does. It does. All right. Let us draw here, circle, center diameter circle. That's the printer that's going. Can you see that? You can. All right, let me quickly have a look at the printer. Just to make sure it doesn't explode. All right, it's not happy. I think I have a calibration problem because I moved it recently and I have to recalibrate and everything. All right. All right. What I will do then is model this and I'll worry about the printer later. All right, so put a circle here. There's another circle on top. Actually, let me bring back the camera just in case. Let me make sure you guys can see this. All right, so I've got the 4 pins here. I will model these. And then I'll give Fusion 360 some constraints to put everything the right dimension apart. Oops. All right. So this is saying, aha. Okay, so this is exactly 1/20th of an inch. 1 inch is 25.4 millimeters, I believe. So a tenth would be 2.54. So this would be 1/20th of an inch. All right, so if this is centered, 1, 2, 3, 4. Whoop! Sorry about that, my bad. All right, so from here to here, it's gonna be, oh wait, this is way too big. This is way too big. All right, let me give this guy a dimension first. Okay, so what's the dimension for this guy? This guy is 2.6 millimeters, so 2.6 millimeters, that's more like it. And then, so 2.6 is like, there's a big pin in here. This must be super hard to see. It's hard to see even for me, but black on black, you know, there's no shading or anything. These 2 pins on the side are plastic pins, and their diameter is going to be 1.55 millimeters. So this guy, I'm going to say 1.55, and then I will quickly just come here and say this guy and this guy have to be equal. This guy's now much smaller. Yeah, I'm probably going to want to add revise these dimensions a bit later, but that's fine for now. All right. Now this guy at the top, 1.4. All right. And at the bottom is the little Pac-Man guy here, 1.5. Ooh, 1/10 of a millimeter difference. You know, this is actually going to make a difference for the printer. It will respect that extra 1/10 of a millimeter if it has to. All right, so now we said that this was what, 4, 1, 2, 3, 4. All right, so 4 times 1 point, was it 27? Yeah. Whoops. All right. D6. Just gonna repeat that dimension over here. I could have mirrored, but the thing with mirroring is in Fusion 360 you'll get far, but then at one point it starts conking out, and it's really difficult afterwards to get your mojo back if you fall on the wrong side of the mirroring logic. So for now, I mean, I'm just duplicating a couple dimensions. It'll be fine. What I'm doing here is I actually said D6. I've computed this value. Just punching in a formula. I'll show you later how we can use parameters. I'll do that to adjust the tolerances around these pins. But here, since this formula has a result, it actually automatically assigned a variable name for D6 in this case. They all have D something. D stands for dimension, I believe. 1, 2, 3, 4, blah, blah, blah. All right, so this dimension here should be D6 as well. All right, and then finally, the guy that was up there was 1, 2, 3. So normally, you know, if you were designing a model from scratch, you could go and parameterize all this. You could change all the parameters, change the spacing and everything, but you don't actually in this case, since the physical device that I'm modeling is fixed, I don't really need to do this. I'll just need to kind of set dimensions once, and it'll never change again. I mean, yeah, I won't get Sherry to change these dimensions on me, nor do I need them to. So this should be pretty close now. Yeah, but as you can see, I'm still free to move these, and they kind of rotate around, so I'm going to constrain them a little more. What I'll do is I'll do this, and then turn this into a guideline, and say this guideline has to stay horizontal. Already been applied. Okay, sorry. There we go. And so if I move this now, yes, that is because this guy and this guy need to be coincident, and this guy and this guy need to be coincident. if I move this now, see it moves as a whole. All right, awesome. Let me save this into a new project. Save this in there, and then whatever. PCB, all right. So, I'm also curious about the actual footprint of this. Okay. Thanks, Daru. I'm glad you enjoy it. It is really cool, actually. It's a lot of fun. I mean, once you've worked with like you know, mesh modeling software like Max or Maya or something like that, you know, you get a hang for modeling, but when you get into solid modeling and you see what this stuff does later on, it's just so awesome. It's just such fun. You'll see, it's really cool. Actually, you know what? One thing I'll do let me quickly, I'll draw a rectangle here around all this. See, now it knows about these regions and everything. It's so smart. And I'm going to do this 11.4 by 12. And yeah, this is not centered. Wait a minute. Okay. 11.4 divided by 1.27. Yeah, that's not a round number. It's 9-ish. Are there 9 grid lines? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's true. It doesn't really come up against the edge. So this would be what, kind of 5/9 of the way up? That can't be right. 1, 2. No, see, there's 10 here. It's 12.7. It's not quite right. Okay, well, you know what's great with 3D printers is it'll take like 3 minutes to print, and it won't be. I can just try it. So if it doesn't work, I'll just try it again. All right. So let's give this guy a dimension. So let's say 12, and then let's give this guy a dimension. So 11.4. Yeah. All right. And then what I'll do is I'll actually, can I extend this? I think I can. There we go. Or removed, constraints are removed. Wait, that's fine. Okay, and I'm gonna say this point must be in the midpoint, like that. So at least it's centered this way. And now I can see I can still move it this way like this. It still solves for all the constraints and stuff. I'm gonna actually go and eyeball this. Oh, wait. Unless this is actually equidistant, is it? Yeah, not quite. I can't even say the pins are the same distance from the edge, and I really don't have that dimension in here. Or at least I don't see it. Let me just zoom out. .08, 3. Oh, it does give it to me. Okay, sorry. So 5.08. This doesn't even line up. That must be like a PDF artifact. All right. So 5.08, 5.08, 5.08, 5.08 from the center line. No, not from the center line. Sorry, from the. What am I looking at here? It's 5.8. Is that a multiple? It is. Okay. So 3.81 must be as well. Just looking at the switch, I would say this is about it. I'm really eyeballing it there. I mean, sorry, what are those two top left and top right circles on the diagram? And there's a plus or minus 0.05. Okay, so I'll answer those two questions in sequence. What are the two top left and top right circles on the diagram? So that's a really good question. There are two versions of the switches. Of the switch, there is another version of the switch that has more pins. Let me see if I can't show this here. There's another version of this switch. Will it focus at all, or is it just too? Yeah. All right, you can kind of see the pins here. It's really stubborn. Really goes up to macro though, it's nice. All right, so you can see that here there are these little holes that you can sort of, not holes actually, they're little nubs in the plastic. There's another version of the switch that has two pins that stick out there, and they literally just have a wire between them, and that's called a jumper. And what it allows you to do is when you're building a complicated keyboard matrix and you need to have like a lot of rows and columns of switches, it's kind of complicated to route all those signals around the board. And so one design that people have come up with for keyboards is that it's you can get Cherry MX switches like this, by the way, as well. Is the switches themselves incorporate a jumper wire, and it allows the signal to jump from one place to the other on the board. So you have a signal, in this case, it might be running this way down the switch, and the jumper is actually going in the other direction. So it allows you to route signals in a grid on the keyboard. Now this version of the switch that I have, it doesn't have these little extra prongs. It only has the signal pins for the switch. My fingers are in a terrible state, I'm sorry about that. And I knew I wouldn't need the jumpers for the design that I was building. Now, I wasn't sure, I was kind of torn. I was like, should I buy the jumper version? Because it's actually potentially more useful. The thing is though, is that I knew there was very limited amount of space in these keyboards to replace this switch. And I figured the less pins I had to deal with, the more luck or more, better chances I would have of being able to design a PCB that would fit properly inside the groove. So that's why I have the jumperless version of this, and I actually don't need to worry about the extra pins that aren't really there. And your second question, you were asking about the plus or minus 0.05. They call that a tolerance. Basically, it's for industrial process. It's basically, they can't guarantee down to like 1/100th of a millimeter that it's going to be exactly that distance. So what it means is that when you are building a keyboard and you're designing your own stuff around these switches, you need to make sure that your design accounts for this possible variance from switch to switch. Now, in my case, so 0.05 millimeters is what is it's 5 microns, 50 microns. Yes, 50 microns, sorry. My brain is a little tired. 50 microns. So that's probably on the order of the precision of my printer in terms of positional placement. I'm not 100% sure. We frequently speak mostly about Z height precision, really. The printer I have does go down to 50 microns. I've never used it that way. I usually use it in the 100 microns, so 0.1 millimeter layers. But XY, I'm not 100% sure. I would assume it's on the same scale. So in my case, that's probably around the limit of the precision of my printer anyways. And whatever. I mean, this is kind of it's a 2-off thing. I can't say it's a 1-off, but if, it's not exactly right, I'll push it in there. I'll push it a little harder by hand and it'll fit. I'll make it fit. All right, go back to it. All right. So now that I've eyeballed this, what I could do is I might actually, just for the purposes of testing, I'm actually going to draw another rectangle around this, and I'm going to give it a, you know what, I'm going to make here's the cool part. All right, modify, change parameters. I'm going to add some user parameters. So test border width, I'm going to give it an extra 2 millimeters. around there. And so what we'll do is we'll give it a distance here. Whoop, sorry. Why is that over constrained? There we go. And then I will, sorry, I think I misclicked. Test border width. And now, as you would expect, if I go and I change that value, everything will update properly. So for example here, test border width. If I go and I change this value, oh, that's a bit of a shame. If I set it to 1 millimeter, there you go. It updates in real time. How amazing is that? And this percolates to every single aspect of the software. It doesn't even have to be, you know, dimensions or whatever. It could just be a constant. The unit could be a constant. So you could do something like, you know, later on I could do like, you know, oh, I need 8 keys. So I put, you know, number of keys equals 8, and then it repeats it 8 times in a row. It's really amazing, the software. I love it. I mean, if I was a pro, I would probably look into this. I'd want to use it. I mean, I'd consider it at least. I mean, there's stuff that you pay a lot more money for that's like really, really robust, but this, man, this really gets a lot done. All right, so now I'm gonna go and take this sketch and make something 3D out of it. So I'm going to extrude this and this. I'm gonna extrude it by, like, say, I'm gonna give it, actually, probably there's a dimension for that in the data sheet as well. There is 2.7. Okay, so I'm looking at this dimension here. That's the length of the pins. So if I give it a 1 millimeter thickness, just for now, there we go. So I've got this nice piece. All right. But what happens is these are very precise dimensions for what's going on with the switch. My printer, when it prints this, the plastic's gonna, like, it's not precise, like, I mean, it tries to get it right, but it doesn't exactly get it right. So I need to actually build a tolerance into this. I need to make these holes a little wider so that they wind up being just about the right size for me. So I'm actually gonna do something crazy here. I'm gonna go back in time. Doo-doo-doo. Oh, I meant doo-doo-doo. And now I'm back up to sketch. I actually don't need to drag this back. I can leave it there at the end, and I can just go back and edit the past like this. And then once I'm done and I update my sketch, it'll go and play everything back in the future if I edit. So if I leave the edit of the sketch. All right, so I'm gonna go and create here. I'm gonna go switch, or the shorter is a little better. Yeah, I've modeled a couple things with super long names, and it gets really cumbersome when you're trying to read everything in that tiny text box. So I'm gonna call this MLTOL for ML tolerance, or yeah, maybe ML hole tolerance. And I'm gonna say, I'm gonna give it 0.2 millimeters. And that's gonna be total on the diameter. Or should I do it on a radius basis, on a radial basis? No, these are all gonna be diameters, so I'm gonna just put it on the diameter. All right, so plus ML hole tall. There we go, hole's a little bigger. Just edit this value here, this formula, plus ML hole tall. And same thing here. Now, I'm glad you enjoyed. It's a lot of fun. It's really cool. So then I can hide this sketch. Now, the thing is that you can see here, this is the border of where the switch will wind up, but I don't really care in terms of like plastic, you know, if I have to extend it for now. I just want to be able to test the fit and everything. And when eventually I have multiple of these, actually I can mock this up right now. You'll see what I can do. It's really kind of cool. If I was to go and say, all right, let me try something. I'm going to suppress this feature for now. I'm going to go and create a box, a really big box like this. Boop. And then I'm going to extrude it for a bit. And then what I will do is I will extrude, and hide this body for now. I will extrude these as holes instead. I want to unhide the body. It's going to figure out that it needs to cut. You can change this, but it's like, oh, well, you're trying to extrude something through something else. You're probably trying to cut. And indeed, I am trying to cut. And I'll try to select this profile as well. I was missing that center hole. There we go. I was just complaining about the fact that it was cutting through something that wasn't visible. All right, so now I'm going to cut this. And now I can do something really cool, which is, I think it's, there we go, pattern. So in this case, I want a rectangular pattern. So objects, patterns, I want to pattern the feature. And the feature that I want to pattern is, can I select this? I can, there we go. Direction, select. I'm gonna go and select, I think I can select this edge actually. There we go. And I can do this. Like that, and quantity 3. Okay, wait, sorry. What's going on here? One direction, blah, blah, blah. There we go. So I can now actually edit this feature and change the length. I'm not sure why it's not previewing actually. I think it has to do with the type of operation. I could make this, whatever, 5. I can go and, you know, let's drag it out a little more. I could actually make the 5 a parameter. So if I went here and said, you know, num keys or something, and then I don't want it millimeters, I just want no units. So I'll say 5. And then in this case, I can go and re-edit this feature and say, oh, I want this to be num keys. There we go. So now my number of keys is 5. If I go and I change the parameter here and make it 4, it actually, does it update in real time? I think it doesn't, but I think that's due to the same problem I had earlier. If I set it to 3, then what happened there? Wait, did I punch that in properly? Okay, wait, num keys. Oh, there we go. So I must have hit the wrong key there. Anyways, you get the idea. I can actually go back in the past and change a bunch of stuff. I can change the shape of this thing if I wanted to. You can see when I click on it, it selects this feature in the timeline. I could go and like, whatever, I could do a bunch of stuff, but that's not what I'm trying to show here. I guess I will delete, wait, unsuppress feature, and then delete all features after history marker. There we go. So back to square one. All right. I spent a long time learning how to use this tool. Not that much actually. I mean, you know, sort of every project I do with it, I learn a bit more, I gotta admit. You know, I can't say I make a habit out of watching people do it or use it either, but there is a really cool channel you guys should check out if you don't know it. It's a band I love. It's called Vintergatan. They made this really cool marble machine. You probably saw this video a little while back. You know, this guy plays music with his crazy marble machine. And so this guy, Martin Mullen, his name is, he's actually building another marble machine. It's called the Marble Machine X. And he has a super nice series of, super nice series of videos about how he builds these things. As it turns out, actually he's using Fusion 360 as well. And his case is so complicated that like eventually like he got to speak with Autodesk, with like the product director at Fusion 360 on air about his problems with the scale of the models that he was trying to create. You know, they found some solutions, but certainly he's pushing the limits of what the software can do. And you know, I think everybody has their own way of using the software. Everybody kind of thinks in modeling terms a little differently. There's multiple ways to get to the same result. You know, I could have, you know, instead of for example building the, you know, as a sketch and then extruding from that, I could have just built a box first and then, you know, drawn a bunch of cylinders and then subtracted the cylinders from the box. Personally, I find that the sketch is a little easier to work with, especially when you have really precise dimensions to work with. They're all kind of in the same place and you can edit them all. But one trick that he taught me, or that I learned from watching his videos, was that D trick I showed you earlier, which is punching in the name of a dimension that Fusion computes for you. So yeah, I mean, you learn, you know, here and there, and actually they have really good forums. They have something, I've never used this feature, I don't even know where it is, but there's a way to screencast as well. So you can cast what you're doing directly into the forum so people can help you. They can cast back to show you how to do stuff. It's super useful because you know, it's better than a picture, so it's a million words, right, to describe exactly how to do something. So there's a really strong community around this, and Autodesk, I think, is putting a lot of weight behind it as well. They're really pushing it. I've seen a lot of publicity for it and stuff. So yeah, I mean, in terms of learning how to use it, I really don't think it's that complicated. I mean, for what I'm doing, right now I'm doing something quite simple. I've done more complicated stuff before. There are things in here that I've dabbled around with, but I haven't really don't know them that well. Like this is a freeform modeling thing for you know, organic shapes. Will you? This assemble is more for yeah, exactly, assembling components. So you could do, you know, model hinges, joints, and other types of constraints. And then there's a whole flow here for working with sheet metal, for working with, well, you can render stuff, you can animate, you can simulate to see stresses and stuff. For example, this is a bike fork. CAM is really cool. I'm sure I'll get into this one day, possibly with my laser cutter or laser engraver, whatever. You can do machining, so CNC machining with this. I'd love to have a build or buy or whatever CNC machine one day if I have more space, or if I find a small one, I'm not sure. And yeah, so you can do a lot more with the software. I haven't explored all of it, but it's definitely worth your time. You know, if you're into 3D printing at all, I really recommend this. There's another popular one online called Tinkercad. It's much simpler, but it's very accessible. It's a lot of fun, and if you're building, like, you know, simple shapes, project cases and stuff like that, it's definitely great. SketchUp also kind of does the job. SketchUp, though, doesn't deal with it. It's not a solid modeling tool. You can edit faces and stuff like that. You can have non-manifold surfaces, which kind of leads to bizarre situations when you're trying to export the model files that are required for 3D printing, which are STL files. If your geometry is not closed, you kind of need to fix it up and stuff. So I haven't really used SketchUp all that much for 3D printing. Yeah, so without further ado, I could try to figure out how the printer, if the printer is stuck. Let me have a quick look at that. Let me see. What I'll do is I will, first of all, turn it on. My switch is faulty. Very faulty. And then I'm going to ask it to warm up so that I can level the bed. I'm going to get out a screwdriver. Now see, it's not great that I need to level it again. That means that either the desk on which I run it normally is not flat, or that is not flat, or not sure exactly, or maybe I kind of bent something while I was moving it. It's not awesome. So I just adjusted a screw there. That screw, this screw over here, is part of a piece that I printed that allows me to adjust the height of the printer as a whole. I have a really cool gizmo actually that I haven't fitted on the printer yet. It's in a box right now. It's actually called an auto leveling head, and what it does is it kind of just probes boop, 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 the print bed in sort of a grid pattern, and so the printer is able to sense the distance between the bed and the nozzle, so you get amazing prints every time. But and that should be fairly simple to install. Just a bit of a soldering job, and just need to print a bracket for it. What worries me a little more is that I need to change the firmware on the printer. I need to, well, clearly it's going to be an upgrade. I need to use this open source firmware called Marlin, which is super popular. I look forward to using it. I've used it on other printers before, and it's great. It's a great time. I look forward to it, but you need to make sure it's configured everything, properly, that so you're not gonna, oh, there it is moving. All right, let me see what's going on here. Actually, I have a feeler gauge that I can use. Let me quickly take out the right thickness. see what's going on here. All right. Wow. Wow, it's not even remotely close to level. Not even remotely. Okay, so let's screw it again. There we go. Wow. Wow, it's not even there. All right, you know what? I'm not going to do this on the air. I'm not going to waste your time and mine. I will figure this out some other time. Because it seems like it's quite a bit off. All right, so next thing I could do, I suppose, is maybe model some keycaps. I wonder if I have the dimensions for this. Oh, actually, you know what? I think I don't have this here. And I think, if I remember properly, a guy's already 3D printed these switches, but he used a very fancy printer. I think it was an SLS. Let me... Yeah. I think he had the dimensions. It was like some round, that's it. Some round number, like 1 millimeter by 3 millimeter or something. Yeah, this is the one. Okay. So mine is not the ML1A11JW, it is the ML1A11NW for no jumper. So this guy had the features about the jumper and everything. He's modeled it pretty precisely, it looks like. So this looks pretty nice. Oh, actually he has proper dimensions for this. Oh, very nice, very nice. Three by 1 mounting posts as a test. All right, thank you, Corey.ly, Corey Lee. Thank you very much. Please don't mind if I make use of your dimensions. So this said 5. Let me look at this. Put a dimension here. 6, really? Okay. So, oh no, sorry, that's the wrong dimension. Here to here, there we go. Okay, I was pretty close. All right. So this guy says what, 5.3 between the posts and 1.1, and this is 3.1. So he said 1/3. So his printer is pretty good though. All right, let me make a new model. Oops, new design. All right. You know what? I'm going to go and create some parameters first. Well, post width. Yeah, sure. Post height 3. There we go. And now, you know, I'm not sure if there's a better way to do this. I keep creating these like construction lines. To get the center of my shape, I will create a, actually no, I should probably take this line, extend it. Yeah, see, because this point is on the, there we go. And then what's the dimension here? 5.3 center to center. Oops. Oops. This. There we go. So I'm not sure this is the most efficient way to do this. But it'll work. And in my case, this is not quite right. This is not quite right. Dimension should be from here to here. All right. And then I don't even know what these keycaps want to look like really. Actually, one of the things that's interesting is I will need to mount these switches sideways in the keyboard. So normally, I think in normal keyboards, these switches would go sort of like this being the top of the keyboard and this being the low side of the keyboard, such that the fact that they're off center, off the center of the switch, I'm trying my best. Try your best, please. All right. So yeah, you can see that it's not quite in the middle of the switch. Normally, I think the top top of the keyboard would be that way and the bottom would be this way, or the opposite. But in my case, I actually need to mount it sideways, so the top of the keyboard would be this way or that way. And so the center here will not be, actually the keyhole for the switch will not be aligned with the mechanical part of the switch that moves. And you can kind of see that here. If I move it closer, you can see that it's not aligned in the hole. You see it's a bit closer. Oops. Yeah, it's a bit closer to the bottom right now. You see it's not aligned in the hole exactly. So I need to design the keycap with that in mind. I think it'll be firm enough that it won't really matter when I start pushing those buttons, but we'll have to see once I have it printed. So back to it. All right, and he actually has the dimensions for that. If I wanted the keycap to be centered completely, so let's actually draw a key switch like this. Whoops. I keep forgetting to put my dimensions. That would be 11.4 and that would be 12. Is there a way to align maybe? There's a way to align in 3D, but I don't know if there's a way to align in this sketch, because you really want to constrain more than align. Alright. Alright, and then I'll create a line here, to here, and then this. Yeah, I want it to be constrained on one direction, but not the other. Actually, instead of 6.5, let me just, so to avoid the confusion, because I frequently look at the switch from the other way, the other direction, I'll put the 5 at the top. If I try this, I don't think it's gonna like it. It's gonna say it's over constrained. Yeah, because it's trying to constrain both midpoints of the line. I mean, what if I drew a point on this? All right, and then I said this point is coincident. That, aha, there we go. That's the way to do it. Awesome. Is it worth, Daru says, is it worth shifting it so that the switch part ends up centering in the keyboard holes? So that's a great question. I was trying to show that earlier, but the thing is that the switch itself actually fits super well in the keyboard, just the way it's mounted already. It's like exactly aligned. It's exactly 11.4 millimeters wide, the hole in the keyboard. I mean, it's uncanny how well it matches. So I don't think it's worth offsetting the switch so that the the mechanical part is centered in the hole. If I did do that, I would have to move the switch further back into the keyboard in order to not use the grooves that are already there. And that means I'd have to make the switch, the keycap longer. And also I think the whole PCB assembly would be deeper. And I'm not 100% sure how much space I have in there. I think I have enough, to be honest there. Yeah, but it feels like I think I'm gonna try to use the existing grooves that are in there. It's just too much of a too nice an opportunity to pass up. And because the keycaps are gonna be super shallow, I think it's gonna be really nice, the feeling. I won't get like this weird wobbly feeling because the keycap is super long and you're pushing on a switch that's actually super far from the tip of the keycap. So I'll try it this way, and again, as I said, you know, like 3D printers, it's awesome. It takes a few minutes to to iterate on the design and just crank out another piece. I think what I'll do is I'll probably finish the design for this keycap, and that might be it for this evening. You know, to move further, I think I need to sort out the 3D printer. I'll do that for sure before the next stream. Right. So yeah, so I'll try to put together a nice something cute for this keycap, or maybe something cute. All right. Actually, what I'll do is I'll measure the holes and I'll see if I can't get a notion of how much the offset is. Actually, I can because I know the size of the key switch. Let me look here. Let's see what's going on. So I've got a caliper here. This is a digital caliper, and as you move the jaws and so on, it tells you the measurement. It's like a really smart ruler, basically. You can use it a bunch of different ways. Here, I'm not going to use this side. I'm going to use this side, which measures inside dimensions. You can see as I slide it apart, the jaws kind of move to fit inside holes and stuff. So I'll flick this over. And then in theory, all of these holes have the same dimension. I say in theory, but I'm pretty sure they do. That's 8 point... Let me see there. Well, this one's kind of crooked actually. So 8.8, 8.8, 8.9, 8.8, 8.7, 8.7, 8.7, 8.6, 8.6. So they're not all the same dimension, but it's possible there's, you know, human measurement error here. I may not be, you know, measuring the exact right angle. I may be twisting it a little bit or something. But definitely this row is not flat, so I'll have to kind of keep that in mind. I have seen the version 2 of this keyboard, and there are little grooves around the edge. If you look at the way that it's built, I wonder if I can see a picture here, but if you look at the way that it's built, well, you can't really tell from these tiny pictures, but there is a bit of a gap here between the edge of the keycap and the hole. So I'll bank on the same thing, and I can see here that they're all flat. Yeah, so it's a flat PCB. Oh, is it? Oh, I don't know. This key looks like it's curved. No, it's all flat. Okay. Yeah, my keyboard was like that at the start as well. It's flat behind, and this key just sticks out a little less because it's curved. All right. Phew. All right, so let's say that this is what, an even 8.7, I would say was maybe the average. 8.7. So that means that if I was to go and model this 8.7. Now in this case, 8.7 will be kind of on this axis, so I would go, and I'm actually going to draw another line here on this midpoint because I want it to be centered on that axis. There we go. And then I'm going to draw a line that is, oh, I forgot to measure the okay, well, wait. Okay, I gotta measure the other dimension in the hole, this dimension here, which is, what, 11.8? 11.9, 11.8, 11.9. 11.8. All right, 11.8. All right. So I said 11.8, right? Yeah. Okay. Modify. Let's just call it hole. Well, in this case, width and height are going to be different things, but this means from the outside of the keyboard, facing it in a natural angle. So I said, what did I say? 8 point. Was it 8.8? I think it was 8.8. Yeah. All right, 8.8. And then here, whole height is going to be 11.8, I said. All right. So I'm going to draw a rectangle here. And this dimension is going to be whole width. And it's going to be whole height.
Okay, I'm gonna move this so that this I'm gonna use the same trick actually in Sketch. Draw a point in the middle of here, and I say this and this have to be coincident. So then this can only move on this axis now. And then I'm going to do the same thing here again. Create a point on this guy and say this guy and this guy have to be coincident. All right, so now this looks promising. All right, and then I'm going to do, so what I've done here is this profile here is the hole in the keyboard as it should align with the switch. The bigger rectangle is the switch size, the switch footprint. And yeah, I will create a tolerance for that. Tall. Go and point. Well, so we got to remember that the switch is actually going to be moving here back and forth. The keycap's going to be moving back and forth in the hole. So I'm going to go 0.3, but on either side, because this is not a radius. I haven't really settled on a convention here for the tolerances, whether it's on either side of a gap of a hole or if it's for the sum of all sides of a hole. And I'll explain that some other time. That was a poor explanation, I'm sorry. So I'm gonna render, or not render, but draw another rectangle here. Say this dimension here has to be hole tall. And then here is going to be hole tall as well. And then this is going to be hole tall. Hole tall. All right. Oops. All right, I'm gonna go and create the parameter cap depth. So make it 5 millimeters thick. And I'm also gonna do the post depth. I make those 2 millimeters thick. I think was, this guy is, yeah, 2 millimeters thick, right? Yeah, okay, awesome. His design is really nice, got the fillet and everything. We could do that too, but I don't need any round surfaces really. Actually, as it turns out, I'd love to be able to print this with the pins, the posts on the underside of the print, because I really like the finish that I get on the top side of my prints, which I know is kind of backwards. Most people prefer the finish on the underside, but I happen to really like the top side finish. So we'll see. I will extrude this and this, post D, and then I will extrude this. I will extrude it from object, and then the distance will be cap D. And I also want to select more profiles. It's kind of weird. Oh, is it because I'm using the same object? Wait. Okay, this works. Weird. So there you can see. It will be cool to see this printed. I can't wait. I wish the printer worked. I mean, I could show you, but I kind of tore a hole in the tape that was on my bed there. It's off by like actually a couple millimeters, which is really surprising. I need to mount it on a more solid base so that it doesn't get crooked every time I move it. But it'll get fixed. Don't worry about it. It's quite a sturdy little machine. All right, so that's a cute cap. Now here's the question: do I want to make this any stronger? I suppose I could. I could chamfer these. Well, I want to see what this guy did though. He chamfered them slightly, or drafted them rather. I suppose I could do that too. The thing is, though, I don't really want to chamfer them, because so just to show what I'm thinking about here, what you could do is you can do this. Well, yeah, I could chamfer the bottom, but what I mean is I don't want to draft. So like, for example, this. Plane faces like this. So if I was gonna see, I could do this and have the legs kind of taper off a bit. But what I'd really like is them to be able to fit without this, because I think then I'll be able to fit them all the way in, and they won't be like slight variations in the depth at which they fit within the switches, the Cherry MLs. So I'll try it without this draft. And we'll see. I will actually try to print. Well, the thing is, if I print this like this, there's going to be all this oozing on the underside, but I don't really care because we're not going to see this. What I do care about though is the topside finish. So, all right. Anyways, let's worry about that later. What I'll do for now, I can hide the sketch. Is I can fillet these 4 edges, because why not? A millimeter or 0.5 millimeters, say. There we go. Kind of rounded. I don't know if I like that though. I don't know if I'll like that tactile feeling. We'll see. I'll make it less of a. There we go, like that. And then just for fun, for this print, let's see if we can't actually add some text for fun. Let me print F1. Oh, very nice, very nice. Nicely done. Okay, let's see. F1, all right. I don't even know what the font is they use on this. Let's pick a cool font. Let's pick like Consolas or something. All right, like that. That's not the right size, nor the right dimension. So 90, is that? There we go. I don't know if the switches are going to be like this or like this inside the keyboard, but let's just try this for now. F1. So I'm going to go and make this a little smaller. A little smaller still. I'll worry about more precise positioning later on. I'm not sure I want to emboss this in the final product. I'm just trying stuff out, you know, for giggles. There we go. And then I'm going, I think for text you actually have to press pull instead of extrude. There we go. Press, sorry, not project. Create, modify, press pull, selection. Yeah. There we go. That's it. The first time I was trying to extrude it and I fought and I fought and I fought. F1. There we go. Ah, I see. Sorry, any thoughts about etching in the legend? Yeah, I could etch it, I could print, I could etch, I could do a number of things.
You know, I could, for example, raise it a little bit and just dunk it in paint or something like that. That probably wouldn't stick too well. I see you sent me a link. What does this say? Keyboard fonts. Oh, really? Due to the nature of double shot molding, vintage keycaps use more rounded typefaces. More exquisite typography. Huh. I'll have to read this in more detail to stub. Okay, well, it doesn't matter. I'll have to read on this in more detail. I didn't know people had ideas about this. You know, this does give me an idea, though. It does give me an idea. I will... see, I'm not sure I can edit the text anymore. Unfortunately, I can. All right, phew. Let me make this 6 for now. And then move it a little more. And then, can I copy that? Yes, I can. All right. Whoops, that's not what I want to do. All right, like this. There we go. And then I wanted to... Not sure why it's confused about this feature. Whoa, what is going on here? Oh, okay. Sorry. And I'm gonna press pull this guy, but up. There we go. I've got one sticking out and one being embossed. That should be interesting. You'll need enough room for the whitest text. Yes, that is correct. Right now, I just want to check. I suppose I could reduce the font size to make sure it'll fit. I just want to kind of see the feeling. But yeah, you're right. You're absolutely right. In fact, if I recall properly, F10 is not even the widest that I have. I think F12 is even slightly wider. Is it? I think, yeah. It's about the same. And I have these weird ones, like the ones that say, like, you know, remap eject F12. This one I think says, like, welcome to Jamaica and have a nice day. You know, a bunch of little tiny writing. I won't be able to reproduce that. But it'd be nice to be able to get at least the major... Oh, wait. What's this? ESC for escape. That is definitely the widest one. This one here. Can you see it? It is completely worn out. Bingo. All right. So let me go back here and edit the sketch. You see. Whoops. And then, oh, that's pretty spaced out, eh? Ugh. All right. Whoops. There must be some kind of way to align these, but what happened there? I think I might have to, like, yeah, I'm not sure. Ugh. Yeah, the text editing in this program is not the best. All right, ESC. Oh, that is some fine detail there.
All right. So next step is pretty simple actually. I'm going to export these. First I'm going to name the bot. Wait. Okay, wait. This guy here. Edit feature. Join. There we go. Now we only have one body. Earlier I had 3 bodies there. It's not quite what I wanted. Keycap. The big A. All right, and then for this guy, let's call this PCB just for now. Not the final PCB, obviously. And then what I can do is I can export this as an STL file, which is what I need in Cura to 3D print stuff. So I'm gonna have to tessellate this very high. You can control the refinement options if you need, but the high setting is very good. And then I will save that. 3D printing, Dropbox, blah blah. PCB, and then this guy I will go and save. Whoops. All right, keycap. And then I'll show you all the way until I'm ready to print, but I won't print tonight. Oh. Okay, I will have to go back to the other computer, which means unfortunately the microphone is gonna be a little crap here, but hopefully you can still hear me. However, this does mean that that I get 2 monitors, so it's a little easier for me to follow things along. All right, so let me try Cura, because I was in remote desktop, so Cura doesn't run with OpenGL over remote desktop. It's actually funny that this would come up because I have a friend from work, Alvaro, who ran into this exact problem on a work task. I believe it was 2 nights ago. All right, so what I can do here is I can import the PCB, and in this case, it doesn't really matter which side we print it. Yes, ANET, blah blah blah, quality 0.1, sure. There's a million settings in here, but they're all pretty much set up already correctly. The only thing I need to check really is this build plate adhesion skirt. That's perfect. And infill is going to print at 100 anyway, so if I prepare this, there we go, layer view, so you can actually kind of see what the printer will do here. It's got 9 layers to print, and that's actually a trajectory of what the printer head will do, and all the walls and the indoor geometry and all that stuff. So I will save this to file. No, that's not the right folder for this. I've got three. Okay, wait. A PCB, and we can get rid of this, and then start a new one. The keycap. This one like this. I am going to try to print this upside down. I'm really, well, no, it's not going to work actually, because there's too much of an overhang here. If I put supports, I could try with support. Let's try with support. All right, infill 20%, cooling, support, generate support, placement everywhere, overhang angle 65, Well, more like 55 is the maximum angle. Concentric, will that work? Well, let's see what it does. Support density 10%, support blah blah blah. Okay, what is by default? And then all right. Let's see what it does. Let's see what it makes out of this. So the blue stuff is support. That actually looks like it could work. That'd be fairly easy to tear off. Support line distance. I think I might actually need to put a little bit more support in there. I think. Well, no, actually, you know what? Actually, you know what? You know what? I think 10% is good. There we go. These are gonna suck though. These lines here. Yeah, I'm gonna. Oops. All right, that looks more like it. And I can snap this off with a knife afterwards. Hello. All right. Oh, where'd the where did the what happened there? It's kind of surprising. It just like gave up. Oh, maybe the feature's too small or something. So yeah, so I'm kind of hitting limits here. All right, let's see what it does. I'll save the file. And that, my friends, is that for the evening. I think that's it for me. I will endeavor to fix the printer and maybe crank out a couple test pieces just to make sure everything works before the next stream. Thank you very much for joining me. I hope you had a good time, and have a good night. See you soon.